Hi again, Peter Cutsey with another of my online briefings. Today we're going to cover an engine failure just after V1 on takeoff. So pilot monitoring would call engine failure. In this case, we've lost engine number 2. And the situation is a flameout. Later on in my briefings, we'll talk about other types of engine malfunctions after V1. Today, we'll cover the first type that you'll do in your training, which is the least complicated as far as procedural items is concerned. All right, you fly the airplane. And if you notice over here, we've seen this little picture before in the introduction to an engine out in one of my previous videos. So the secret is to input the correct amount of rudder so as to centralize the control wheel. And I'm sure you remember the pictures that we talked about before. All right, so let's go back the main menu. And an engine failure after V1, we'll have a look at what the FCTM says. The FCTM is your Bible. This is what Boeing have stated. They're the aircraft manufacturer, so we follow the FCTM. All right. On takeoff and engine failure, Boeing say differences between normal and engine out profiles are few. One engine out controllability is excellent, and it truly is. During takeoff and after liftoff, minimum control speed in the air is below VR and VREF, so you can actually control the airplane easily. Okay. An engine failure at or after V1 initially affects yaw. We've already talked about that, like a crosswind effect. Vibration and noise from the affected engine may be apparent, and the onset of the yaw may be rapid. Excuse me. An engine seizure, which is severe damage, the yaw would be very rapid. Your instructor will take you through gradually with the easiest engine malfunction as far as yaw and handling is concerned as the first. And that's what we're looking at today is a flameout. Rotation and liftoff with one engine inoperative. If an engine fails between V1 and liftoff, maintain directional control by smoothly applying rudder proportionate with thrust decay. And you'll do that with practice. Your instructor will give you practice to do it. Excuse me. During a normal all-engine takeoff, smooth continuous rotation towards 15 degrees of pitch is initiated. Now, Boeing say, however, the target pitch attitude is approximately 2 to 3 degrees below the normal all-engine pitch attitude. The normal all-engine pitch attitude is 15 degrees. If you target 12.5 degrees of pitch, somewhere between 12 and 13 degrees of pitch, you'll be fine. The rotation rate is 1.5 to 2.5 degrees per second. So you're looking at a timing of 5 seconds. Remember, your timing with 2 engines on rotation is 5 seconds to 15 degrees. But on a single engine, half the amount of thrust, the rotation, 1.5 to 2.5 degrees per second. The timing is the same, 5 seconds, but your pitch reference is 12.5 degrees. So what, to make a long story short, is count to 5 and rotate smoothly. Now you'll find that the 737 pauses at 10 degrees as you're rotating through 10 degrees. There seems to be a dead band on the elevators at that point. So you will have to increase the amount of pressure as you pitch through 10 degrees of pitch to your target pitch of 12.5 in order to have a constant rotation rate. You'll see that, and your instructor will show it to you. Okay? Here's a picture and just what I was mentioning, 5 seconds. Retract the landing gear after a positive rate of climb. The pilot monitoring will call a positive rate when he will call positive rate, or whatever your SOPs say. Generally, it's positive rate when he or she views a movement in the barometric altimeter. Don't use the IVSI and radio altimeter. You can use all three, but what you must ensure is that you don't call positive rate till the barometric altimeter moves, and it's last to move. Important. The pilot flying on hearing positive rate will double check that she or he, in fact, has a positive rate before calling gear up. Okay, your instructor will go through that and we'll have a look at some of those calls a little later in a schematic that I created for you. Okay, so let's slip back to the main menu and just have a quick look at trimming the airplane. You trim the elevator or the horizontal stabilizer with the slide type switches on the control column, and you trim off any pressures as needed. Remember, you trim last. You put the airplane where you want it with elevator, then secondly, trim off the forces with horizontal stab trim on the control wheel. You also have a rudder trim. The movement of the rudder trim, a little technique, is such that when you move the trim knob to its limit, and incidentally, do that without looking. Practice on the ground and moving your hand back to find the turn knob. You're comfortable. Moving it to the limit for 10 seconds will give you 5 units of trim. And that's a good starter for an engine flame out at average weights on takeoff, somewhere between 4.5 and 5. But please don't look down at the trim indice. You're flying the airplane. And you'll find that on a count of 10 seconds, will give you beautifully somewhere close to 4.5 to 5 units. That is a technique. It's not written anywhere, but it works beautifully. All right, so the little pictures I've got here, the one on the right in red, you need a lot of right rudder. The amber, you need less right rudder. And the green picky is where you should be. You've got the correct amount of rudder input. Okay. Engine failure in the initial climb, your command bars will command you to maintain a speed of V2 to V2 plus 20. Remember, when you rotate, you don't use your command bars. You rotate using that 5-second count at the rate that we spoke about, and smoothly rotate to 12.5 degrees. Then look at your command bars. All right. So that is basically the little bit I wanted to show you about the climb. If you have to turn after takeoff, the turns will be listed in your standard operating procedures or on an airport chart or the instructions for an engine failure from that airport off of that runway, you follow those procedures. Turns are not normally made below 400 feet above field elevation. And if you have to turn, you're limited to 15 degrees of bank until your speed is at V2 plus 15 or greater. And that's very important, and it's here. And in Boeing's FCTM, it's not me saying it, it's what the manufacturer is saying. You are allowed an overshoot of 15 degrees momentarily. So if you're not at V2 plus 15, you're limited to 15 degrees of bank with a 15-degree overshoot up to 30 degrees momentarily because of gusts, etc. Right? So that is important. You know that, and so you will study that from your FCTM, of course. There's a great tool you have on board for tracking the center line. Most, if not all, engine out procedures that you will fly, you will be tracking the center line or the extended center line until you're at least at 400 feet. If the engine out procedure calls for a turn, it's not normally done below 400 feet. And in many cases, it's done at takeoff flap setting, meaning you don't change flaps setting. Therefore, you will maintain takeoff speed of V2 to V2 plus 15 for a minimum radius turn. And in most cases, you will be restricted to 15 degrees of bank as a precaution in the event that you are below V2 plus 15. Most carriers will have you select a bank, the pilot monitoring select a bank limit of 15 degrees on your command. When I say your command, I mean pilot flying. We'll talk about that shortly. Anyhow, what we have in front of us is a super tool to maintain that runway track. The dashed white line is an extension of your center line of the runway and extends for 14.2 nautical miles. When you line up on the runway before touching toga, you will see your aircraft symbol here. And the tip of your aircraft symbol should be lined up on the white track line. This is your actual track line. And the track line will be actually lined up with the dashed extended center line if your map is okay, and it should be okay. You shouldn't have a map error. When you touch toga, you will get a map update. So your map will be right. All right, your instructor will teach you that. Okay, this is a scenario here taking off on runway 12 left at Dubai International Airport with the runway track of 120, 119 later on, but somewhere, let's say 120 degrees with a crosswind on my example today of 25 knots. So 90-degree crosswind from the right. So to get back what I was talking about, if you put the airplane symbol on the white track line and overlay it on the extended center line, you'll track the center line. So here's a situation where you are slightly to the east. You are slightly to the southeast, to the right of the center line. All right. So you want to get back to the center line. So you make an attempt by turning left in this case with a small amount of bank, not a large amount of bank, a small amount of bank, and use the 30-second trend noodle as a guide. Use the tip of it. There's the tip of the 30-second trend noodle, which is a super tool. It's saying under these conditions, crosswind component, headwind component, tailwind component, regardless, ground speed. I know that if you put the tip of me on the extended center line, which is overlying the actual track, I will put you on the extended center line. So use that tool. And you'll also use that tool on a raw data approach when you're doing an ILS further on down the line. All right, so let's go to the main menu. Here you are getting closer to your track. There's your actual track, a track of 114 degrees. That's your real track, your magnetic track. The white dashed line under here is your extended center line. So let's go and have a look at the next one. Now you have lined up the actual track of 120 degrees over the dashed extended center line of the runway. And if your wings level, you will stay on the extended center line. That's how you track your extended center line. So that's important, really important. And if you notice, here is your heading, and it's approximately 7 degrees. So your heading is approximately 127, which is 1/3 of the wind. 8 degrees, I should say, 128 degrees. 1/3 at 90 degrees is a good formula to use for most jet aircraft. All right, so use that and you'll do a great job in tracking. Autopilot engagement. In the FCTM, they specify the FMC update 10.7 or later. If using the FMC update 10.7, you have restrictions in that you have to bug up at 800 feet, clean up, and when flaps are up, lights out, then you go ahead and select level change or VNAV, whatever you're doing, but normally level change. With FMC update 10.8 and newer, you will be arming VNAV before takeoff. At 400 feet, VNAV will engage, and at 800 feet, as set in the FMC CDU for an engine out, if that's what you set, in most cases, that's what it would be at 800 feet. Could be higher. 1,000 feet is used in training, but 800 feet, you will see the airspeed bug actually move to flaps up speed. If it didn't, you would open the speed window and bug up, and then retract flaps on schedule. So that's important. So for the FMC 10.7 or earlier, if you happen to have that series of update in your airplane, your autopilot engagement is normally delayed until the flaps are up. So with FMC 10.8 or later, you may engage the autopilot, may, at a minimum of 400 feet. I say may because initially you'll find, if you're a first timer on a jet aircraft and this is your type rating course, you'll find that you'll probably be more comfortable and get a better feel of the airplane to delay autopilot engagement until you are comfortable with the amount of rudder that you've inputted and with the fact that you are actually tracking the center line. You don't want to get too busy, and that will come gradually. Remember, as pilot flying, you ask in manual flying, you ask the pilot monitoring to make all MCP inputs except for the actual autopilot engagement. You will do that yourself as pilot flying. So that's important. So we talked about FMCU 10.8 or later. All right. So let's go back to the previous page and let's have a look at a little pictorial that I designed to make it easier for you. And this could be used for any carrier. You may have your own SOPs that require you to do something different, but basically you want to think about an engine out in 4 blocks of airspace. The block of airspace between the runway, which is, we're going to use field elevation for our references. So between field elevation and 400 feet above field elevation is block 1. Block 2 is between 400 feet above field elevation and 800 feet above field elevation. That's block 2, where we're going to talk about things. And then block 3 is between 800 feet above field elevation and the minimum sector altitude for that airport, the minimum safe altitude, say, within 25 nautical miles, and that's on your Lido chart or on your JEFI chart. You can find out what it is, and that would be part of your takeoff briefing. A little caveat: if there's a database engine out procedure, select the procedure as per your company SOPs. So let's go backwards, and you're flying the airplane, pilot flying, and nothing is said basically between takeoff and 400 feet, except perhaps engine failure or engine fire. Or if you're not sure, engine malfunction is a smart thing to say. You do not, and I emphasize, you do not give the engine number in case the pilot flying puts the incorrect amount of rudder and you end up in a disastrous situation. And if you're not sure, say nothing. Basically, it's quiet time. At 400 feet, if you've noticed, I've got basically 2 items highlighted. Pilot flying will call for heading select because in most cases, you'll be in LNAV following a departure procedure, which will not be what you want. You want runway track to 1500 or the engine out procedure, whatever it dictates. So heading select and identify are the 2 major and most common actions that the pilot flying would call. So there are a few others, and we've discussed them already. Set the bank limit to 15 degrees. If required, it may be required that you're going to turn with a minimum radius turn as per the engine out procedure, which means you would do it at takeoff flap and at speed V2 to V2 plus 15. So you'd want to set the bank limit to 15 as a protection to not exceed 15 degrees of bank, because your limit until you're over V2 plus 15, V2 plus 15 or greater, you're limited to 15 degrees of bank. Okay. Open the speed window of ports if required, if you were going to maintain V2 speed as per maintaining takeoff flap. And VNAV, if in FMC update 10.8 and greater, VNAV should be armed, should be engaged at 400 feet. You armed it on the ground. That's FMCU 10.8 and later. So all of these things come into play, and that would be part of your takeoff briefing. Okay, so that's kind of in a reddish, light reddish or rose color. As we get above 500 feet, you're getting safer. That's why we've gone to an amber reference. But 800 feet above field elevation, not runway elevation, very important, because the actual terrain may actually drop out of the runway, and you wouldn't be above field, or you wouldn't be 400 feet above field elevation if you used your radio altimeter. So very important you stay with field elevation. Observe the speed bug moves up to flaps up speed if you're using FMC update 10.8 or greater, as we've discussed, and then begin to clean up. And otherwise, if you're using 10.7 or earlier, set flaps up speed, bug up, clean up. So you would ask the pilot monitoring to do that unless you were engaged with, or the autopilot was engaged. Remember, you can't engage until you're 400 feet. So when you get used to the airplane, you'll be engaged in the autopilot at 400 feet minimum, and you'll make your own inputs on the MCP. We don't talk about a very important word that I learned 62 years ago when I started flying, called airmanship. Airmanship is common sense and doing all the right thing. There's no book on airmanship. Airmanship dictates that if you're not comfortable, even with the autopilot engaged, if you're not comfortable and you're still trying to input rudder with your feet or trying to trim, please don't reach up to the MCP and try to do a third thing. You'll end up having big problems controlling the airplane. So your instructor should really point that out to you, even though that your manual says that pilot flying will make her or his inputs when on the MCP when engaged with the autopilot, use your head. Okay. The only reason I'm telling you that is many times I've seen exactly the opposite. Everybody rushing to follow what the book says and finding out they're losing control of the airplane because they're too busy looking up to the MCP and not flying the airplane. Okay. Remember that slip skid indicator has to be lined up the way I showed you. And it's very, very, very tiny at the top of the PFD. So you've got to focus on that, anchor pitch, and you'll be fine. Okay, so once the flaps are up and the light's out, in either case, if you're using 10.7 or earlier, it's level change MCT. If it's 10.8 or greater, it's MCT. All right. So then you continue climbing, and once you've achieved the minimum sector altitude, you're free now. There is no bank restriction. Hmm? And you're free to increase bank or whatever. Aviate. You've heard this before. And I've been teaching for 60 years, and I've been telling my students for 60 years, aviate, navigate, then communicate. You fly the airplane first. You navigate, you know where you're going. And when all of that is organized and you're stable, then you communicate. And it's the pilot monitoring that's doing the communication. You are communicating with the pilot flying as a pilot monitoring. The pilot monitoring will do the communication with ATC. Nothing elaborate, just short. And it could be Mayday, it could be a PAN. It's whatever the captain decides to tell you what to do. And then you're going to get in touch with the in-charge flight attendant as you get squared away a little later. And then, of course, much later with your company. Now, that's just a guide. You're going to vary some of these things, and it's very important. And notice here that in gray, if you're going around and you should have an engine out on a go around, normally you do what your SOPs say, but normally you don't start cleaning up until 1,000 feet above airport elevation. But follow your SOPs, all right? So here again, another little note, if going around with an engine out, follow the public missed approach procedure, okay? Unless your operational performance tool or your company SOPs require a non-standard engine out procedure. Okay, so that is a very brief rundown on an engine flameout. The engine flameout doesn't require any memory items. You get involved in checklists. So you aviate first, you navigate, get going towards a holding point, whatever the engine out procedure dictates. You've navigated, you communicate, and then do a quick assessment before you get into a checklist. Just do a very quick DODAR, we call it. Diagnose what happened, just very briefly. Did we do the right thing? Yes, it was a flameout. Were there memory items to be done? No. Or no, we had stall, engine stall. We should have done memory items. Oh, we better do them. So just a very quick reminder of, did you do the right thing? Yes, we did the right thing. Now, checklist. Checklist is last. Don't rush into a checklist. Happy flying. See you in the next video. Stay passionate.